Today's an introductory session. This series of sessions, like there are 16 different sessions we'll cover, and we'll cover multiple services that data engineers use, and mainly focusing on data engineering with AWS. So if you want to either shift your career towards that, or you have some introduction, but you want to get your basics better, this course will help. Little bit about the course before I go about myself. So we'll cover these 25 services, some of them very much in depth, like Redshift and S3 and Glue and Kinesis and like Athena we'll cover very much in detail. Some of them is like KMS, IAM. We'll get a good introduction so that you know how to use it at work. So we'll definitely cover those to that extent. Today, given it's an introductory session, we're not going to have any hands-on exercises, but over this course of the 16 sessions that we'll have, actual sessions, we'll have some hands-on experiences where you could log into your AWS account and then set up certain infrastructure. But what we cover today is we'll go through the overview of services. For those who've done Cloud Practitioner, this should be similar to what you've learned during Cloud Practitioner exam. And then we'll also kind of leverage looking at how real data architectures have been used. In my experience, I've worked in a few different environments. So I'll showcase whatever I've seen, and we can talk about, or if you have any questions, you can talk about those architectures. I have been working in IT for the last 18 or 19 years. For the first 10 years of my career, I was in ETL, mainly in data stage in Informatica, Teradata, Netezza. So the just data warehousing part of the world. Then moved on from data warehousing to big data. When the big data shift happened, naturally my teams moved towards Hadoop and Spark. So I started learning Hadoop, Spark through my project, and then it evolved into AWS for the last 5 years. My previous job, I was actually working with Amazon as a AWS data architect. Now I'm working for a startup, helping out their ecosystem. That's a little bit about me. What do you need to get through this course? Today, you may not need this, but over the course of our actual sessions, I would ask that you bring your own AWS account. If you don't have one, create one. Most of our work will be in free tier, but not everything. Like in data engineering, any big data tasks in EMR typically are not in the free tier. So you might incur some charges, but what I say is this is a good cost to learn. You can always create the resources, and as soon as you're done within that day, if you just remove those resources, you will typically incur minimal amount of additional charges. I also ask that you have your own GitHub account and Git installed locally on your system that you're going to practice with. Have Visual Studio Code or any other preferred code editor. Even if you don't know how to code, we can get through that. But having this installed and set up will help you. Having an AWS CLI, either on your terminal or on your Windows local machine. If you're using Windows, I also suggest using WSL2 or Linux on Windows. Yeah, I think most of us are aware about what cloud is and what AWS is in this call, but I just had the slide just in case people are very new to cloud. Given both of you have good experience, I think this should be pretty easy to follow along. So AWS Cloud was the first cloud offering provider and is still the leading provider of cloud services. It's being fastly followed by Azure and GCP and Oracle and so many other competitors in today's world. But yeah, what Amazon did with their excess computing was that they had a lot of computing power that they did not use. So they thought that can be something that can be put to use by many companies who need computing power. So the way they operate, they provided it where they just provided the basic servers itself, that is infrastructure as a service, IaaS, and then they offered certain applications and virtual desktops, that is kind of a platform as a service, and they also provide software such as like Glue or Kinesis, which is also a SaaS. So they provide IaaS, PaaS, and SaaS. So they provide all those things through their cloud computing architecture. All we need is our network to be connected to the AWS through the internet. And within the AWS, you can actually wall out your network using VPC and stuff like that. We'll go through those when we go through those sections. But what does it do? It provides cost-effective, scalable solutions. So you don't have to buy your servers before you build something. You don't have to like say only for this week you are going to have an event and a lot of people are going to buy your products. And say you're an e-commerce provider, a lot of people are going to buy your product for the next week because you're running a promotion. You don't have to buy a new server to accommodate for the high load for that week. Rather, you can scale it when you need it and then scale it back when you don't need it. So that way it's scalable. You can build applications fast and cost effectively. Okay, any questions before I go on? Today we'll cover a few services that we use. Last session I covered a few like S3 and few services that we typically use like Kinesis and stuff like that. I covered last week, but we'll go a little bit further this week. Any questions before I go on?
Yeah, we're good for now.
Okay. Okay, let's cover the first for today, EMR. Any big data environment that we use, whether it's a Hadoop-based environment, say Hive or Flink, or if you use a Spark-based application using PySpark or Scala, those need a lot of computers, and those computers need to coordinate with each other. So we call them nodes. Multiple nodes need to work with each other for us to do the computation. So this is typically done used for analyzing and processing large data sets. For those cases, Amazon solution is EMR, where it provides multiple EC2 instances. If you don't know what an EC2 instance is, I'll just step back one second. So EC2 instances where you can rent out one particular server or a virtual server on like for whatever you want to install on it. So you can set up an EC2 instance, and then you can install your own web application on it, or say your database on it, or your say you want to have a database server, so you put an Oracle on it, and then you set up, you put in the data into it. So you can do that. You can do those kind of things. You can put your own like front end installed on it, or you can just set it up such that your developer can log into the EC2 instance through SSH, and they can just use it as though it's their laptop. So they use their My Documents on their laptop, and they can set it up like that. And EC2 can be done using Linux, Mac, and Windows, and multiple versions of Linux are available. So it's a very flexible like server that you can rent. Now let's come to EMR back again. So EMR, now we want to set up, say, 3 executors, 3 nodes, and we want to set up a Hadoop environment or a 10-node Hadoop environment. So we rely on EMR to coordinate those EC2 instances together and to be able to work on those as a cluster. So for setting up a cluster, you don't have to set up like 10 different EC2 instances, set them up, install the basic software on them, and then install Hadoop or Spark on them, and then start doing your code. You can set it up using EMR steps. So we can go to the EMR. I'll go through the front end and show you. It simplifies the setup and configuration of that. And then it supports various big data tools and frameworks. You can use Hive, you can use HBase, you can use Presto, Flink, like whatever your team needs, whether it's one of those big data software, all those can be installed when you install the EMR itself. It also integrates with other AWS services. Definitely integrates a lot with S3. You can integrate with Redshift, DynamoDB. Like you can also like mount. You want to mount any storage. You can do EFS. So you can do all those whatever Amazon services are there. It can easily integrate with those. So essentially, you want to set up any Hadoop environment or a Spark environment. You want to set up a cluster. You want to set up multiple resources. For those, you use EMR. Any questions? Okay.
No, Anant.
Good. Yeah. We can probably go through Amazon Athena, and then we'll go to the UI and see some examples here. Amazon Athena is an interactive query service. So when you have a data set, you have a file. It can be a CSV file. It can be a JSON file. So you have those kind of files. You don't know how to interact with those. Like you want to programmatically interact with those. You want to filter out and figure out how many of them are ordered on this date. So if it's a file with a lot of orders and it has order dates on them, if you want to filter out only the orders that were done yesterday, so you could write a query and then you can run that through Athena so that it can query that file. So this is based on Presto. The Presto service is being used as a base for Amazon Athena as a tool. So the open source tool Presto is what is used as an engine for Athena to be possible. What is the advantage of this? You don't have to load your data into a database, transform it, make sure the data types align. We don't have to do like analysis of the large data sets, and then index the data, do all those things, right? You don't have to do any of that. As long as your file is in S3, you can query that data by defining a table on top of it. Next thing you can do is you can provide fast query performance through distributed query processing. So you can like have multiple partitions and then have all those partitions work in parallel so that you have huge performance benefits. So if you have like 10 files and you want to query them all at once, Athena will do parallelly process all those 10 files, and it's able to provide a much faster query performance. It won't do it one after the other. It can do it. It can do 10 different files in parallel. It mainly integrates with AWS Glue for schema discovery and cataloging. So all the schema that we defined, that is the databases, the tables, everything, it goes into Glue, and that's where we see it. So let's take a quick detour onto AWS and see how this is defined in AWS. So as soon as you log into the AWS console, so you, both of you used S3 and Athena. So you guys are at least aware of like the files and structure and stuff like that, right?
Right.
Yeah, I've used S3, not Athena also.
Okay. Santosh, you've used both, is it?
No, Anant, I have used both the things.
Okay. Okay. So let's probably look at Athena. So Athena is a querying tool. So how do we get to there? I probably can navigate there. So as soon as you get into your console, either you will find your recently visited here, or you can go in here, look for services, and look for Athena. Again, search for it, and then get there. After that, what Athena does for you is organize your data into just like you do it in Oracle or in like SQL Server or in Netezza or Teradata. You organize those into different catalogs. I'm using the default catalog, and then you organize that into different databases. So I have like 3 different databases set up, and then within those databases you have different tables set up. So for this example, I'm going to say like look at the data in the NFL stadium data. So if I want to do that, I either go here, hit the 3 dots and say preview table. That runs a select statement for me. It runs a select star from the database name dot table name and has a limit 10. So it pulls in the first 10 files from here. But I told you this is actually a file from S3, right? So let's look at how that works. So if I look at how this table was created, I can just do show create table. Is my screen visible? Sometimes my size is too small.
It's visible.
Okay. Okay. So when we do a show create table, I don't need the quotes here, I'm sorry. But when we do a show create table, it shows us how this table was created and where this table is located, where is the actual file in S3 located. So if you look at this is an external table. If you know Hive or Presto, you understand these. So we use the names external table in Presto or Hive to actually define these data types on top of this file. So this file that we're looking at is actually in this S3 location. So if I go to this S3 location, there is actually a file that is delimited by commas. So what that means is it's a CSV file, comma separated value file, and it's just looking at text as a text file. It's not a what that means is it's not a special file like a Parquet or a ORC file, which are special files where it has certain characteristics. Like JSON and CSV are text input format files. And then the way I created this table was using a crawler. I think last session I covered what a crawler is. So crawler is a glue service that can actually look at your file and say, oh, this file seems to have these fields, and these fields look like it's string and string and string and big int and string. So crawler is a glue service that can do that. I'm not going to go into that today, but I'll show you the crawler and the table that got created in glue. So what we see here is this stadium data has these fields, and this file is actually in this location. So if I want to go here, I'm going to copy this location and show you that location in S3 that has the file. So I'm going to the S3 console, and these are all the buckets I have. And now the bucket I'm talking about is this particular bucket, which is in Asia Pacific region, and like it has every object as non-public. So I'm going to go inside that. And then within that, I'm going to look for this location that I found from the table. So within that location, within tickets DMS sample NFL data, or let me go through that. So tickets DMS sample NFL stadium data, I believe. Yeah. So NFL stadium data, I have the CSV file. So this CSV file has those fields, and we define it. We define the DDL there, and that helps us query this file. So tomorrow I have like 10 more files in the same schema. I can load them into the same location, and Athena will be able to query all of them, and it can do it in parallel. So it doesn't have to read file 1, then file 2, and file 3. It's highly scalable. So if you have thousands of files inside the same folder location, again, folder is not the right terminology to use in S3, but we use it interchangeably. If you use it inside the same folder location and have multiple files here, all those files will be seen. So let me also show you that this file has the same kind of schema or fields. So now I can go click on this, and under actions, there's a option for me to query with S3 select. What that does is, just like a SQL statement I do in Athena, I can also do something in S3 as well. If I do query with S3 select, and then I know this is a CSV file, and Amazon, because the extension is CSV, it assumes it's a CSV file. So it asks you if the format is CSV or JSON or Parquet, but because I know it's a CSV, I'm going to leave it like that. I know the delimiter is actually a comma. If not, I'll have to change this. And then I know there's no compression. Sometimes it's compressed like a bzip or zip or something. And I want the output to be shown as say a JSON. I want to just see it with column names and stuff like that. So if I do that, and I want to see the first 5 records, I run this query. And what that does is it returns the first column as stadium, and the second column as seating capacity, and the third column is location. But what it did not understand is the first column actually has a header. So I should have done this. So enable the setting if CSV contains a header row. So I need to do this and then rerun the query. Okay, this looks better. So the first 5 records, stadium is this, the seating capacity is some million, and then, sorry, 93,000 or something like that. And then the location is here, surface team. So it reads it like this. And this one is the only thing defined in the table as a big int. But if you look at this, even this probably seems like a big int. So those are things we'll have to like look at and think about. So if you look at this, I see this is a string, maybe a big int, definitely an int. All others are strings. Let me go back to the Athena table and we'll see how it was defined. So it was defined as a string. Opened alone was defined as a big int, which I don't know if we need a big int for that. It's just a year, right? So maybe just an int is enough for it. But yeah, this is how it was defined. And I spoke about how this was created by a crawler and about glue. I think I covered a little bit of glue last time. I didn't really show how this was done. So I'm going to go there, go to glue. Glue is kind of where your table gets defined. So Athena is the place where you can actually query. But these databases and these tables are not stored here. There's actually stored in a catalog called glue catalog. So that's where we're going to go. So this is the glue screen. So it says welcome to AWS glue. Glue has multiple things you can do. You do all your ETL serverless inside this. So you can do all ETL here. So anything that you do in Informatica, anything that you do in like data stage, SSIS. So if you have used to those tools, yeah, those things can be done in glue. But not only that, you can connect your data stores. It's most Informatica, SSIS, you do have connections to data stores. So that is similar to that. You can also orchestrate jobs. It's something like if you want to use Control M to run your jobs, or if you want to use what are the other orchestrators? Yeah, any other orchestrators that you use to. Yeah. So if you want any orchestrators to build your pipelines, that can be done in Glue as well. You can also manage and protect your data, which is like you can check the data quality. You can check if there's sensitive information. And then you can clean do data cleansing, data quality. But most importantly, it also has a data catalog. So here it stores all your databases that you use in Athena and stuff like that. So that's what we're going to look at today. So data catalog. So there are so many other functionalities I'm not going to cover today, but I'm just going to quickly go through this. Data catalog settings. I'm going to save. Here under the left, I see that there are data catalog, ETL, and some other pages. So I want to look at data catalog. So what I have under that is I can look at the databases that I've defined, tables that I've defined, streaming that I've defined, any connections to other databases, like I have a Oracle database or a Teradata or a any other database that I want to connect to, any AWS databases as well. So Redshift, DynamoDB, all those connections I can define here. And crawlers are what looks at the data and figures out what schema there is. So let's first look at database, tables, and crawlers today. So databases. So these are the three databases that we saw in Athena. So those are actually set up here. So we can change, if you want to change anything about the databases, you can change those here. You can edit here and change the types here. Within this database, we have these tables, and these tables are defined in this catalog. So it tells you what table, which database, which location it's under, and then it has some information about quickly viewing the data and stuff like that. And you can also change, like for example, I want to call my like birth year. I don't want it to be big int. I want it to be int. So I can go here, edit your schema, and say, let's call this year actually as an int. So I go click here, edit, and change that into an int. That will reflect in this, and it will also reflect in Athena. So this is the base for where it's stored. So I can do that. So any questions until here?
Yeah, another one question. So if you go a step back,
Sure.
where you have all the database, the same where you have all the tables and databases.
This one?
Yeah. So the location which is mentioned over there, so is this the location of the actual files where it will decide, or it's the location of this configuration of this table?
No, this is where the actual file is.
Okay.
So this one, if I open here,
Yeah.
I can actually see the file that has this particular data.
Okay, and you said like if we'll have 10 files over there, so the same query, like if I'll run select start from table name, it will query all the 10 files, right?
Exactly. Yeah, I don't have an example here, but I can show it later. But yeah,
Yeah.
if I have 10 different files, it should be the same layout.
Okay.
Otherwise, it won't work. But yeah, if I have 10
Yeah.
files of the same layout, yeah, you can query it like that.
Okay. Thanks.
Okay. Yeah, if you have any questions, stop me there. Then thanks, Vikram. Yeah, so these tables are where actually our files are. So this name data is actually under this location. So this location, and tomorrow if your ETL process adds more file to this location, your Athena table just starts showing those records as soon as your ETL process is done. Or if somebody goes in and uploads, one more file there, yeah, it's going to start showing up in the Athena
And is
queries.
this name should be same, like here the last path is name data, like if we say second one, and the here also the name is the same. Is it like mandatory?
That's how we typically do it in Hive and Presto. You can
Okay.
have exceptions. Yeah, I mean, that is the best practice, I would say. But when you create your table, you would actually say, I want to create the table name as XYZ, but the folder is actually NFL data. But that might be confusing to certain people and certain like logic as well.
Yes,
But a good
yes.
question. Yeah, good notice that you notice that this name and that are same. Yeah, typically this name is the last folder name.
Okay.
And yeah, when I look at crawlers, I'll show you this. This will come up as well. That particular example will come up as well. So that's a good
Yes.
pointing. Okay, so yeah, the next thing I wanted to cover is we saw database and tables. We'll skip the other ones. We'll go to crawlers. So we created these tables using crawlers. That means I didn't go and say each of these files have these fields, and those are string versus not string versus int versus big int versus stuff like that. I didn't do all those things. What I did was I went to I created a crawler which actually crawled my data set. So this is the crawler. So let me actually go one step back. So if you look at these tables, all the tables are under the same location until here. Just this part has the table name on it. So this location for all these tables, forget about these two tables, which are in a different database. Let me probably, yeah, if you ignore these two, right, I can filter it, but if you ignore these two, everything else is in the same location. And they're all as CSV files. Now, if I go to the crawler, if I have 10 different files that a source is providing, and I want to figure out what the schema is, right? I don't want to go inside each file and check what the data type is, how many fields are there, which is what field, right? I can create a crawler and run it. So this is that I actually ran it, but in one of the hands-on exercises, we'll actually run it and show how to do it. So this crawler, what it does is it goes to this data source. So if you look at this data source, this is the data source. It matches with the table's top level. And we tell that, can you crawl every file under this location? So it goes to this S3 location. Let me look here. So it goes to this S3 location, which is what we say in the crawler. Can you go inside this location and figure out all the tables inside it? So it goes inside this and it checks, oh, there are like so many tables. And it checks that inside this, there's actually sports team. And within that, there's actually a parquet. So even if there's a different type of file, it can actually crawl it out. Wait, let me go to an easy example of CSV for today. Yeah, so if it goes under NFL Stadium data and looks at this file and figures out what schema there is, and then it defines that schema in.
Okay.
So back to the crawler. Any questions here?
No.
Okay. Yeah, there are multiple settings here. Again, we'll go into some hands-on in a little bit later session. Let me go back to where we were from. So we spoke about EMR, which is mainly about big data, and about Athena. Athena can handle big data and small data. So I just showed you some small CSV files. How do you do it? But Athena can handle big data as well. That is the reason for scaling. So they can scale to thousands of Parquet files. So I've done in the most recent healthcare project that I'm working on right now, in fact, we have petabytes of data. There's like 12 petabytes of data in the Athena database. That is what is used by the tool. And so every like doctors and clinicians who use the data, they just use it from Athena. So they on their screen, they just have to choose filter by this and filter by that. That will actually run an Athena query in the backend, and it will produce results, which is again, it's a petabytes of data. It's really impossible to do it in like even a Netezza or a like Redshift or maybe you can do it, but it may be heavily expensive, and you might have to have a server farm with like thousands of servers, not hundreds of servers, thousands of servers to be able to have petabytes of data. Most of like I've seen terabytes of data, hundreds of terabytes of data in like Teradata and Netezza, but petabytes of data Athena can handle. Okay. Now we move on to lake formation. This is another service we'll use. As a data engineer, you don't have to know it a lot, and it's a very easy tool. I will show through how it's used. We may not have a hands-on for this. But before I go there, any questions until now? Okay.
No.
Not from my side.
Okay, good. So let's move on to lake formation. So lake formation is where when we want to set up a data lake, it takes a lot of steps. So first of all, you need to say where your data lake resides. If you don't know what a data lake is, let me quickly tell you in 1 or 2 sentences. So data lake is a place where you can dump like any data that you get, old, new, whether it's images, whether it's Word documents, somebody's emails you want to archive. Customers send you chat messages and you want to archive them. So it's text, so you can't really store it in a database. Customer calls. So your company's customer call center gets a lot of calls. You want to store the audio, or you want to store the transcript of the audio, that is the text version of the chat. You want to store all that somewhere. You can store it in a data lake. So data lake can take structured and unstructured data. So it can take everything, and it can we choose a very cheap data storage. So we don't choose like expensive Oracle or Teradata and stuff like that. We choose cheap servers, cheap non-proprietary servers. So if you go to IBM and ask for a server that can store a lot of data, they're going to charge you a lot of money. Rather, if you can buy the generic version of server, but you're able to store a lot of data, that is what data lakes are. And this is how Hadoop started. And this is the data lake started first when Google and Hadoop did not know how to store so much of the data, and they wanted a solution for it. So Hadoop, Hive, Spark, those are all mostly open sourced from either one of these startups like Google, Facebook.
This device isn't set up yet. To get started, download the Google Home app on a.
Sorry about that. Yeah, so that is a data lake. So let me go back to lake formation now. So now that you want to set up a data lake, it's not an easy process because you want to set up a lot of data. You want to know where your data resides. You want to know who has access to it. So you want to just like manage a database, you want it to be as easy as that. To manage a database, you can create user, grant user database, grant user table. So those are things that database is able to do. But in a data lake, we have to do all those things. So what AWS lake formation does is tries to do those things for us. So now I'll go back to what it says here. It's a managed service. That is, AWS provides that service. It helps us simplify the process of building the data lake. How do you set up the data lake? Securing the data lake, provisioning access, and managing the data lake. So tomorrow you want to add something, delete something, drop a table, create a table, all those things. Right? You can manage all those things in lake formation. What does it essentially do? You can create a data lake just in the UI within lake formation. You don't have to go into multiple places, go into S3 and say this is part of the data lake and this is not part of the data lake and stuff like that. And you don't have to go to Athena, Glue, and catalog it. You don't have to go to multiple places to clean it and transform it. You can do most of the things from lake formation. It also helps you to secure your data in a scalable manner. You can provide, the last point is the most important, which is what you need to know about lake formation. Essentially, it gives you fine-grained access control. So you can say this user has access only to this column, these 10 columns of this database, or only for US-based rows. So when country is equal to US, only for those rows, this particular person has access. So you can say row-based access control, and you can say column-based access control. based on user. So that is called fine-grained access control. So those things are provisioned in lake formation, which is the most reason why people choose a lake formation. Okay, so let's go through for the next 10 minutes, and then I'll go through a quick architecture of something that I've built and worked on. So the remaining slides I'll quickly breeze through. Not very important as a data engineer, but you definitely need to know these. So we know about S3. S3 is where we store most of our like it's a cheap storage, object storage that Amazon provides. But Glacier is a variation of S3 or a separate service within S3 where you can archive your data. That is data that you don't need immediately. The customers don't want to query immediately, or they don't want to get this immediately. They just want to keep it safe. So those kind of data can be put into a Amazon S3 Glacier. It's S3 is the low cost service. Amazon S3 Glacier is even more low cost service. Typically used for long-term backup. Say you want to back up something for regulatory purposes, but you know nobody's going to query it. So regulation says these account transactions should be kept for 7 years. But you know after 3 years, nobody's going to actually go query those transactions because it's not going to be shown on online banking. Online banking shows only 12 months of data. If a warehousing system, if somebody wants to do fraud or tax analysis, it shows only for like 3 years of data. So you know it's not needed for now, but because regulation asks it for it, you can save it somewhere, but you can get it back in say 6 hours or 12 hours or something like that. So if you want it, you can get it back. For those kind of use cases, we typically use data archiving. I think both of you worked in financial institutions, insurance, right? So there's a lot of regulations in those. So you must have seen those kind of use cases.
Yep.
Yeah.
Yeah. Okay. So similar to S3, it's durable. That is, you can keep it for a long time without data loss. It is secure. You can provide access only for the people who need it. And it also has certain flexibility with respect to retrieval options. Some data you can say, I really don't need it as much. So give it to me in 24 hours, I'm fine. Certain you can say, give it to me in the next 3 hours or something like that. So what it does is it puts it in a tape and moves it to a different out of the cloud connected location. So when somebody requests for it, so the tape is actually physically retrieved by a robot, and then it is connected back to the cloud into the cloud network, and then you can actually read the data. Again, this is mainly for lifecycle process, like automation of your lifecycle policies or data archival, those kind of scenarios. The next one I want to cover is Event Bridge. Again, this is another one you definitely need to know, but you're not going to be questioned on it on this, or you're going to use this on a regular basis, but this is not something as a data engineer you need to specifically know. Any AWS user will have to use these. So Event Bridge is, if you used it earlier, you might have heard of it as CloudWatch events, but Event Bridge is essentially if you want to trigger something daily at 8 a.m., if you want to trigger something hourly, or if you want to trigger something whenever a file lands. So whenever a file lands, you want to process it. You want to trigger your ETL process. So those kind of scenarios is where we use the Event Bridge. I am, because of time, I'm not going to show it today. But yeah, this is something we will see in one of our like data pipelines that we build. It allows users to capture the AWS services. That is, if you get a file and you want to call a ETL function, the event will actually say, this is the file that landed. The file name is this. It landed at this time. It landed at this bucket. Now it will tell the ETL, these are the things you need to know to run your job, right? So ETL needs to know all those things to run the job. So it actually captures the event, and then it can trigger like Lambda functions. It can put it in an SNS topic. It can put it in it can trigger an ETL glue workflow. So it can do all those things. So it has flexibility to start a lot of AWS services. And it also captures information that can be used by AWS services. main uses are you can do real-time event monitoring. You can route, like if this comes here, then route it here. If the file comes and it's actually a JSON, call this ETL job. When it's a CSV, call the other ETL job. So you can route it. You can define rules and patterns. So you can do those kind of things. Yeah, within AWS, it has pretty good connectivity within AWS, and for third party, there's some kind of orchestration available. So if you want to call an external service, like for example, one example I've seen is whenever a job fails, this event bridge will actually call a ServiceNow API, and it'll raise a task or issue there for somebody to look at the failure. So it captures all the failure, calls the ServiceNow API, and then it does it. That's an example of integration with a third-party application. And based on that event, that API gets called. Okay. So we'll talk about SageMaker again. As a data engineer, you may not use this, but you might help data scientists build, train, and deploy machine learning models. So in my last 5 years, I've been a like Hadoop or big data, worked in big data Hadoop for the last 7 to 10 years, let's say. But most recently, most of our work is to help data scientists build AI data models, machine learning models. So that's what data engineers are being used for. Earlier, it used to be that we build data lakes, and there used to be some analytics run out of it. But analytics is just a very simple way of running queries. Now people want more than just running queries. They want it to be like actually run a R or a Python machine learning model and understand which is a fraud transaction versus which is not, which customer interactions were good versus which are bad. So they just don't want to. The earlier days of understanding how much sales was there for each location, for each job, is already taken care by most software. So now most of our data engineering job is about helping machine learning engineers. And the reason I'm telling that is SageMaker is mainly used by data scientists, but we need to know that because we would have to, as a data engineer, you will have to help them get the data ready for SageMakers to read it. They may need it in certain formats. Sometimes, like not in my current role, but in my previous roles, the ML engineers just built and trained the models. Deploying the models was my task. So I had to know SageMaker for that. So I needed to know how to deploy it using SageMaker. Even though the first, like the training would be done by them, they'll build the models, and then they'll come to a data engineer to actually deploy it. So that may be a part of your use case as well. So this is something we need to know. But as a service, what does SageMaker do? It's like a Jupyter notebook. It's a notebook where you can go in and model your data. First of all, you can understand what type of data you have, join them, query them, and then you can run your model on top of it, build it, train it, and deploy it. So if you want to go to production, you need to deploy your model. So you can do that using SageMaker. So it's not only a playground, but it's also a place where you can actually productionize it. Yeah, main advantage is it's a Jupyter notebook type environment. That's what data scientists mostly use. So they're very comfortable with that. And they can also share the notebook with you, with other data scientists. So that helps with collaboration. It integrates with all the services that need data scientists and data engineers need, including EC2, ECS, Lambda, like Athena. All those things can be integrated within the SageMaker UI. And if you're not a data scientist, you don't know much, right? You can train your own model because it provides pre-trained models. So you can just choose the model and then train your data on top of it. So you can do automatic model development. You do automatic model tuning. All those things can be done even for people who don't know machine learning. So they are they just know how to use a Jupyter notebook. That's enough for you to get into SageMaker and run your own model. Hey, I see someone else has joined. Hey, Ashish, can you hear us? Okay. So that's SageMaker. I'll cover one more thing before we go through an architecture diagram. Step functions. So this is something which can orchestrate services within AWS, and it's much more flexible than Glue. Glue has something called workflows, which can help orchestrate like service 1 with service 2 with service 3. Within Glue, you can orchestrate the ETL jobs. Glue ETL job 1 with Glue ETL job 2 and Glue ETL job 3 can be orchestrated. But in step functions, you can actually orchestrate a Lambda function, then it can call another Glue job, and then it can call a SNS notification. So it can do all AWS services orchestration in step functions. This is going to be part of one of our hands-on exercises. So we will cover one hands-on exercise with step functions. But let's see how these all get to play with each other, right? So this is one example where we had a bank that had a Hadoop ecosystem. They had everything on-prem, and they wanted to move to AWS. So my role in this was to architect this and help the developers build the whole ecosystem. But if you look at the architecture, what essentially is on the left is our sources. So we have like database sources, Snowflake, SQL Server, Oracle. We have like a lot of files that come in. We had APIs as well. I don't have it in the picture, but we had APIs as well come in. We wanted those to be run in PySpark pipelines within our AWS environment, and then exposed out to users using Athena. So people were Tableau users. They wanted to query the data that was currently in a data mart. So they had a current Netezza data mart, and they wanted something similar that can be done in AWS. So other than the Tableau part, everything else is pictured here. So how was that done? This whole AWS ecosystem was a replacement of Hadoop ecosystem that they had, but that was on-prem. It was expensive. They couldn't scale. So what AWS was able to do is bring in flexibility, scalability, reliability. It was not going down. They did not have to have 10 admins monitor their servers and upgrade the servers, put in patches. So if you have your own servers, you'll have to regularly put in fixes, patches, and that takes a lot of effort. So with EMR, all those were taken off. So let's look through that ecosystem. So we built an EMR. This was a 16-node EMR. So that means there's one master node and 15 other worker nodes. So these 16 nodes work with each other so that they can read files that come in and then connect to the database and then read the information and then write it to S3 into the raw layer. But how do they get triggered? We used EventBridge. I think we spoke about EventBridge a couple of minutes ago. So EventBridge was used. So whenever like Snowflake, these tables were scheduled at 9 p.m. every day. So there'll be one EventBridge rule that we set up. That rule will get triggered every day at 9 p.m. That will call a step function. Step function is for orchestration. So it calls, say, 3 EMR jobs. EMR job 1 waits for it to succeed, then it calls EMR job 2, waits for it to succeed, then it calls EMR job 3. So that work is being done by, that orchestration work is being done by step functions. So after the trigger, step function takes over orchestration. But this orchestration, it actually runs an EMR job. So in EMR, we set up those 16 server nodes, and the step function actually calls a PySpark job. So it calls a PySpark job and says, read from this database. And the PySpark job is a Python based Spark job, which has code to actually connect to one of these databases pull the information from the table, and then write the table into the raw layer. So that's kind of the job one. Job two would actually read 5 of those Snowflake tables, clean them, join them, do some aggregation, like group by, do all those things, and then write that over to curate layer. And sometimes we might also have to do one more EMR job, which kind of summarizes multiple summaries and then writes it again to the curated or semantic layer. And that data was exposed to Athena for users who can actually go into Athena and query, or for Tableau users who can actually connect to Athena and then bring up the dashboard. So the dashboard will get updated whenever we update data into S3, because Athena is just kind of a tool where you can run queries on top of the data, right? So all we have to do is update this data, and then the query will get updated. In addition to all this, I think we have this data lake. This whole data lake is managed using lake formation. And to secure this data, we use encryption. So we use something called AWS KMS key. I think I covered it last week. But yeah, essentially it helps you to store your own key so that you can encrypt the data that you store inside the cloud. Yeah, I was talking about Amazon SageMaker. So here we work with a lot of data scientists who had to build their own models. And because this was a new data science team, we had to bring them up on board with Amazon SageMaker, understand how to use Amazon SageMaker, so those kind of things. So this is typically how the project would go, I believe. At least for me, it was to architect this, make sure the stakeholders agree to these architectures, reason out why we are using this versus, like, here we can, instead of EMR, you can actually use Glue. Why did we choose EMR? Instead of step function, we could use something else, but why did we use step function? So those are things that will come through in a data engineer's or data architect's lifestyle. Work life. So that is what we need to go through. But this is a typical architecture we went through. I'm going to see if anything else needs to be covered for today. Redshift is a data warehouse. Spectrum is QuickSight. Okay, let me go through this architecture quickly. I think we are a little bit out of time, but let me quickly wrap up in the next 3-4 minutes. So data lakehouse architecture is a place where we have both a warehouse and a data lake. So the top line here is the Amazon Redshift is actually a data warehouse. And the bottom layer is actually a data lake. So in a data lakehouse architecture, in this example, I had Teradata as a source, and we moved the data over into Redshift. And when Redshift was ready, we decommissioned Teradata. But we moved data from the corporate data center directly to Amazon Redshift as the end state. So data lakehouse architecture is where we need a lot of reports to be run, but we also want unstructured data to be stored. So the structured data, typically for a lot of reporting, like Tableau or QuickSight, we put it in the warehouse. Here in this example, it's Amazon Redshift, but we could also use other things. But for the data lake, we use all the data that is structured, unstructured, everything we put it in the data. This kind of architecture where we have a lake and a warehouse is called a data lakehouse architecture. Okay. So most other things are like allied services. I'm not going to cover it today due to the time. Okay. What else? So how are we doing? Like any questions for me on what we need to cover or?
So can we quickly touch base on the kind of kinesis part that you're talking about?
Kinesis. I think there's a recording from last week that should have it. I can share that with you.
Okay. Okay.
But yeah, to summarize it, Kinesis is mainly for streaming data. So we
Mhm.
stream data in, and we want to do any events-based analysis, right? So as the transactions happen in a card, you want to know which card transactions are like over a typical range, and you want to flag them for fraud. So those use cases use Kinesis. Yeah, but I think I would talked about it more in the previous session. We'll also do like in one of our working sessions, we'll also do a Kinesis hands-on. So we covered it there as well. So Vikram, any questions from you?
No, Anant. I'm good for now.
Okay. Yeah, I think tomorrow as well we'll have an introductory session. But yeah, we'll get into the sessions from next week. The actual sessions will cover all these services, and like there are like 16 sessions, 8 weeks each. Like there'll be hands-on exercises and things where we do and learn both.
Sure, Anant.
Okay, so can we stop here?
Yeah,
Yes,
sure,
sir.
Anant. Yep.
Thanks,
Thanks,
Anand.
Anant.
Thanks for your time.
Yeah,
Thanks
thank
for
you
your
so
time.
much. Open to feedback. So let me know if I need to, if you think of anything as a feedback. Okay, let me know. Thanks.
Sure, Sure. Sure.
Okay.
Yep. Thanks, Anant.
Thank you.
Thank you. Bye.
Hey guys, can you share your Gmail ID so that you can share the recording with you? We'll give access to your ID.
Okay, sure. Thanks.
No, I think Vikram
Thank you,
left.
guys.
Yeah.
Yeah, I'll inform him.
Okay.
I will ping on
Yeah.
WhatsApp.
Sure. Bye.
Thank you.
Thank you, Anand.